Welcome to our e-course on local manufacturing of turgo turbines. This is the course kickoff session, one of the two live sessions. And the organizations that have made this possible are the People, Energy and Environment Development Association, PEEDA in Nepal, the Nepal Yantra Shala Energy company in Nepal, University of Bristol in the UK. Then there is Energize Nepal and the Turbine Test Lab at the University of Kathmandu, as well as the WISIONS of Sustainability and the Hydro Empowerment Network. And this initiative is part of the SEED accelerator of HPNET, which I'll explain soon. So, yeah, so on the agenda for today is just an introduction, and then we'll have a panel with the course instructors. Then we'll break out to let you share about your work or listen. And then we'll walk you through the e-learning platform. So the Hydro Empowerment Network focuses on knowledge exchange and advocacy in Asia, in the Asia Pacific, Sub-Saharan Africa, and also our members in Latin America. We are multi-actored and we focus on various different themes. The SEED initiative is an initiative where we have seen the regional lessons, hindsight lessons of the last 40 years on what has worked and what hasn't worked, including these various themes. And one of the core themes here is reliable technology. And a key aspect of that is being able to produce technology locally. So this is where this e-course falls under. And there are various aspects of the accelerator, and where this e-course falls under is the exchange part, where we start with offering knowledge to a group, and then we want to further work with all of you, collaborate, so that collectively we are advancing each other's work. Yeah, and I guess the most important thing I'd like to highlight is that there is a real need for our sector to unite. I think all of you know that we are constantly in the shadow of PV battery mini grids, especially, and technologies such as small scale hydro or even others such as biomass, which can be produced locally, aren't given enough attention. And it's also that the type of people that produce these projects are those that have decades of experience, but often not known in the mainstream. So when we do regional exchange, we know there is a lot of effort happening in various corners, but we want to get that out to decision makers. We want to hear your challenges so that we can start to work together towards addressing some of them. Yeah, so I think many of you might have already taken earlier SEED trainings, but so in this course, we will offer 4 modules. The first 3 have been offered in earlier trainings, but if you were not part of them, you have an opportunity to go through them, especially if you have less experience in doing technical hydro work. Yeah, I won't go through these in detail, but this is the list, and you'll see it once you log into the platform. And so now, this will be the best part of the live session. I'd like to introduce our instructors and panelists. Let me just get them on the screen. So we have Dr. Sumanraj Pradhan from the Nepal Yantra Shala Energy company. You should be able to see Sumanji. And Sumanji has a PhD in instrumentation but he comes from a lineage of small-scale hydro development and manufacturing. And then we have Dr. Sam Williamson, and he has a PhD in electrical engineering, which focused on small-scale hydropower in Nepal, and he is part of the Department of Electrical and Electronic Engineering at the University of Bristol. And then we have Dr. Joe Butchers, who is, he's been anchoring this effort, coordinating this. He has a PhD in mechanical engineering, and he's currently a lecturer at the Department of Civil Engineering at the University of Bristol. So let me add him. Should be able to see Joe now. Yeah. Okay. So I will help to moderate this session, and so for now I'll stop sharing my screen. But to start with, I'd like to ask Sam to give us an idea of this effort and how it falls into the general, the wider context and how this effort relates to energy access work.
Thank you very much, Dipti, and thank you everyone for coming along. It's really lovely to see so many people from all around the world here. As Dipti said, my name is Sam Williamson. I'm a lecturer here at the University of Bristol. And one of the things we've been looking at over the last 10 or 12 years is how can we, I guess that question that Dipti had at the beginning, how can we make small-scale hydropower systems more ubiquitous when you have this pressure off PV, biomass, and other systems that are coming through? And I think one of the real benefits of small-scale hydropower systems is that you can make them locally. And this localization of a product such as small-scale hydro turbines has a very large number of benefits. You can effectively use your local capacity and local skills, local knowledge to be able to build these equipment, generating local income. And I'm sure, to be honest, all of you know all of these reasons, but I just wanted to highlight them first of all. We can develop global designs that then can be brought into local ideas. So this Turgo design that Joe, Suman, and are going to be presenting today is this sort of global design that we've developed over the last 4 years or something like that. I can't quite remember. Joe and Suman will be able to correct me on times. But it's something that we've been looking at, working closely with the teams in Nepal and Bristol, and trying to understand how can we actually manufacture this? What does the design need to look like to be able to do that? And then how can we get the design out there so that people can use that themselves? And I think one of the real benefits of localization as well is that you can take that design and modify it for your local conditions, not only in terms of environmental conditions, so changing it for head and flow rate as you all scale already with Pelton turbines and cross-flow turbines and so on, but actually thinking about materials, thinking about environment that you're putting things in, and thinking about what is available in your local market that you're actually able to use and buy, and then modify that design for that, and then feed that back into our system so we can then understand, okay, well, what modifications have other people done? And so what we're really excited about presenting this to you is not only just to sort of show you what this Turgo turbine can do, but also then getting your feedback from that. And that's what I'd really, really love from the breakout groups. Your feedback from that and say, actually, do you know what? We don't really have access to that kind of material, that kind of stock or whatever else, but we can do this and we can do this. And then we can understand more about what your local conditions are and support you and able to actually manufacture this turbine. I think that's I guess one thing to say about this as well is, it's an open source design, so the idea is that it's spread across. So we do not own it. Nobody owns it. You are welcome to use the drawings that we've developed so far, absolutely free. We will use sort of CAD-based tools to be able to disseminate it to you. We've got design spreadsheets as well, and using tools like that alongside 3D printing as well has really enabled this sort of transfer of knowledge and ideas. And so those are the sort of basic tools that we hope we'll be able to sort of communicate with you a little bit more about now. I think I'm going to pass over to Joe, who's going to talk a little bit more about the design in detail.
Thank you very much, Sam, and hello to everyone. I'm just going to share a few slides with me, with you. Hopefully everyone can see those slides.
Yeah.
Yeah? Okay. So I just wanted to give an impression of how we've got to where we are today. So we're really pleased that we're now at a position where we're going to be able to share this open source Turgo design. But I wanted to give you a bit of a history so that you can understand the journey that we've been on to get to this point. So it's come as a result of a two-stage research project based in Nepal. And essentially, we wanted to explore the idea of locally manufacturing a different type of turbine to the ones that are typically made in Nepal, which are the Pelton and the Crossflow. So from 2017, we've been working on this, initially at small scale, and then recently upscaling to construct a turbine of rated power of 30 kilowatts. So initially, we just focused on the runner design. As you'll see from the training course, many of the parts of the Turgo turbine are similar to parts in the Pelton, but it's the runner that's different. So we focused on the runner, and this one that you can see here was cast from bronze and has a PCD of 100 millimeters. And so we tested this at the lab, at the turbine testing lab in Kathmandu, and then installed it in the field. But in the second phase of the project, we wanted to scale this up to larger sizes. So it scaled up from a PCD of 100 millimeters to 225 millimeters in the image that's shown here. And so this turbine now, more as you'll see in a couple of pictures that follow, we've manufactured not just the runner, but also the casing and the inlet pipe work and the other subsystems that make up the complete turbine. That's been installed in a field site in Nepal and is currently generating electricity. And we've conducted some field testing, which suggests water to wire efficiency of approximately 70%. So the mechanical efficiency of the runner is definitely something higher than that, perhaps in the region of 75 to 80%. So the big challenge in making the turbine runner was making the blades. And so the method that we employed was developing the model of the blades in CAD, and then using 3D printing to allow us to make a pattern to sandcast. So what this meant was we could work internationally. So in collaboration also with the University of Lancaster, we did CFD modeling of the performance of the runner. But then we were able to send that the CAD model over the internet and then use 3D printing locally in Kathmandu to make the pattern, which could then be used for sandcasting. So what that means is that we've been able to transfer from a digital design to a physical one that's been made in Nepal. We had to go through a similar process for producing the turbine. So the design was done in collaboration between NYSE and the University of Bristol. And so we developed a full pack of engineering drawings here in the UK that then have been used in Kathmandu in Nepal in order to produce the turbine. So the version of the turbine that we built, we installed to replace this cross-flow turbine, which I think was around 20 years old and was reducing far less than its original rated power. And so we installed the turbine alongside the other one. So we installed this Y section so that it was possible to switch the flow from one turbine to the other. And this is our installed turbine there. So this is a Turgo turbine. I think this image was actually before there was the final concreting of the penstock pipe. And there you can see it's fully installed there. So what we're making available is the drawings for this same turbine design. And alongside that, there's a design spreadsheet. And in just the same way as we use this method of 3D printing and sand casting, in order to use this design, you'll need to have access to those two things in order to use the design as it is at the moment. And as Sam mentioned, by making this design open source, what we're hoping is that the design can be used and adapted for different local contexts and potentially change depending on what's available in different local environments. So there might not just be one open source Turgo design, but different ones for different places. So the design that we currently have, we're calling this the 225 PCD Turgo turbine design. And the way we used it was in a direct drive arrangement. So it's possible to use it with a belt drive, but currently the design that we've developed is for direct drive. Because we have a single runner design and a single casing design, but we know that heads and flow rates vary from one site to another. So it's actually possible to change some of the other dimensions. And you'll see in the drawings that there are dimensions that are labeled that can be changed to allow you to vary and increase the number of different sites that it can be used at. This is the beginning of our journey into this open source Turgo design. And currently we have just this single 225 PCD, but we hope to release further turbine designs for different PCD sizes to allow you to extend the range of sites where a Turgo turbine can be used. So this shows approximately where we think that this turbine design can be used. Below 40 meters, generally it would be more appropriate to use a cross-flow turbine, but we hope to develop the PCD sizes to go on either side of this one, because these are regions where the Turgo turbine potentially could be used. So once you've been able to access the training course, you'll find 4 main videos. And so these cover what is the Turgo turbine, how can we manufacture it, how can the design spreadsheet be used, and how can the drawings and 3D files that are provided be used. So what we would like is you to use these resources, but also provide feedback to us. We want to know what you might change about the design, how you might change the way the drawings are presented. Is there any other additional information that you would use? But yeah, we look forward to hearing your experiences of using the resources. Thank you very much. I'll stop sharing my screen and pass on to Suman now, who's going to share his experience as a manufacturer in producing this Turgo turbine.
Hello, namaste, good morning, good evening, good afternoon, everyone, and thanks for coming over here. Actually, please ignore my name on the screen. So, I'm Suman Pradhan from NYSE, and we are involved in manufacturing Turgo turbine at the both stages in the field of for the prototype as well as this 30 kilowatt as well. Today I'm gonna share some of our experience that we got during the manufacturing process, small one as well as for the big one. Turbo turbine is quite similar to the Pelton turbine. The people who are making the Pelton turbine before manufacturing Pelton turbine, it is not that hard and difficult, different between the Pelton and Turbo turbine. The only thing is some angle in the casing and the bucket set. But however, it is very challenging to make the turbo turbine of the small size like 100 mm PCD. It is very challenging. It's not easy. It's not like you make a peltric set like we used to manufacture in early days. It's very hard to machine, very difficult due to its the angle of the buckets of the turbo turbine. But for the 225 PCD turbo turbine, it's not that you know not that challenging or not that difficult compared to the Francis or this Kaplan turbine. Before I go any further, I would ask Joe to put the small video so you can all have a look like how the manufacturing process we have been through during the manufacturing process of the 30 kilowatt turbine. Thank you, Joe.
This video showcases the processes involved in the manufacturing of the Turgo turbine, along with the field installation at Mungmaya Kola, located within Ward Number 3 of Maiwa Rural Municipality, Sangu, Tablejung.
Joe. As you all saw that notice, all the components, most of the components that we have used over there are very much similar to the Pelton turbine. There is the only thing difference is, like I said before, is the design of the bucket. And being a local manufacturer, like although all the drawings are provided, all the drawings are in place, being a local manufacturer, we always need to find a way to how these drawings we can use in our way rather than just copying the drawing. We always want to make our product different and more efficient and more practical way. Put it in a practical way. It doesn't mean like having said that, oh, this is turbo turbine, we need to get the CNC machine. No, that's not the case. You want to make it locally. You want to make it like in a affordable price for your local community. You want to repair anything that's manufactured locally, rather than have to bring the expertise from abroad or something like that. And yes, I will be very happy to answer any questions that you will have in the next group session. Thank you very much.
Yeah, thank you to Sam, Joe, and Sumanji for these excellent insights and report back from your, now it's been 3 years of development work, I think, with the core of it in the last.
It's been almost 5 years since we started the first phase.
I see. Okay. Yeah.
First phase 2 years, and this one 2 years. So it's already 4 years. So in the middle there was some gap. So almost 5 years. Yeah.
Yeah. Okay. Yeah, we can take a few questions from participants now, but before that, I just wanted to ask the speakers, would you, is there any other thing you'd like to share before we go into questions? Okay. Yeah, I think the way Sam explained of how open source can enrich everyone, and the process, the technical design process, was really excellent. And yeah, and we hope that you share this kind of direction, at least for this turbine. So yeah, are there any questions? You can feel free to put in the chat. We also have time for you to actually just unmute yourself and share your question. Yeah. Otherwise, in the next session, we will be going into breakout rooms where you'll have another opportunity to ask questions. A couple of questions that I have, in order to get to the next version of the design, how typically what time frame do you think would be required, and what kind of, how do you see that process playing out? Like how many tests or models, or what kind of process do you see needed?
I can take this one. So as it is, we've scaled from this 100 millimeter PCD runner, for which we did CFD modeling. And so through non-dimensional scaling, we feel confident in scaling that runner to any size. Along the way, as we have done for this 225 PCD, it's good to confirm any difference that there might be between CFD modeling and what's actually produced in practice. Because obviously the CFD modeling is like an ideal situation rather than the like locally manufactured case. So the fact that we did some local testing and we've got this water to wire efficiency of 70%, which is similar to what is found for Pelton and cross flows in Nepal, certainly. We feel confident in the design as it is. So the other works to develop like these different sizes of PCD. We have a CAD model that very quickly can be changed. It's been made so it's a parametric model. So the dimensions are related to each other and they can all change. The thing that is time consuming is making engineering drawings. So we've done this full set of drawings for the 225. But we will it will take some more time to produce drawings at other sizes. So I think that that's probably something that we can gather from everyone here today is what sort of scale is of interest to people. Is it at the lower end closer to pico or at the higher end, like pushing the edge of micro? But like, if we decide which PCD size we would like to try next, I think with some support, it's reasonable to like produce a new drawing pack within like 3 months at that sort of time scale.
Okay, yeah, thank you. We have one question from Rams who's asking, how do the Turgos fare for 10 to 20 meter heads for 5 kilowatt capacity?
Joe might want to put that slide back in with the graph, the range where the toggle can be used of 2 to 5 PCD.
Yeah, so I won't put this. I can like look for the slide now. 1 second. What the design that we currently have is we feel it's better placed at a higher head. It's possible the Turgo works well at low head, and Sam can give his experience of that, I'm sure. But we were conscious that we wanted to fill this gap between where Pelton and cross flows are normally, and I think you'll see that in the training material. So whilst the Turgo can go to lower head, for this design we were focusing on slightly higher head. So in this region. But perhaps Sam, do you want to share your experience of Turgo at low head?
Yeah, thank you, Joe. I guess the Turgo can I'm going to say very easily be used at low head. There's no reason why it can't. And we've done some sort of experimental testing here in Bristol, and actually at the TTL, I think we did some on the 100 PCD Turgo at lower head as well, Joe, didn't we? I'm trying to remember now.
Yeah, that's right.
And it maintains quite a high efficiency. Obviously the drawback for using it at low head is you've got a lower rotational speed, so you can't do direct drive generally, and quite often you'll need to step up quite a lot to be able to match to a standard generator, and that's the main issue sort of at the lower head. But it is possible, and I say we haven't noticed a drop in efficiency at lower head either.
I think from the 200 watt to 2 kilowatt turbo turbine head is 16 meter or something like that.
I think you're right. Yeah, it was
16
about 15 meters, wasn't it?
Yeah. Yeah, so it's possible. Like I said, the only difficulty for the small turbo turbine, like uh, uh, 2-3 kilowatt, 4 kilowatt, this small turbo turbine it's very difficult to machine. Otherwise, there is I don't see any problem of using the one. The one question I got from Mr. Ramaji is like a 5 kilowatt for 10-20 meter head. I think for that it's better to use a cross flow turbine rather than turbo turbine. It will be a lot cheaper and easier to use that one.
Okay, yeah, thank you. And then I think this has been mentioned, but do you want to recap the minimum maximum capacity with the current design that you have?
Yeah, so it depends on the head and flow rate. And for what the design that we had, because of the head was high enough to have direct drive. If it goes lower, then it will then you'd need a belt drive to match with a like synchronous generator speed. But so looking at sort of low end being like 40 meters head and like 100 liters per second, which will be around 30 kilowatts mechanical power. And then high end would be like 90 meters head with 175 liters per second of water. And that would be like around 125 kilowatt shaft power. So there's a big range with this, with the single design, but then you, with the lower head, then you would need to incorporate a belt drive to get the rotational speed right.
Okay, thank you. And then one last question. Would you say for the 3D printing and casting, there's a certain level or type that's required?
So in Nepal, it's generally is sand casting that's used, and so that's what the casting companies there are familiar with casting buckets for Pelton turbines. The 3D printing, there's like it requires a certain like bed size because to print the pattern of the blade needs to be of certain dimensions. We were able to do the 3D printing for the small one on a smaller bed that was available at the turbine testing lab. But then we used a different company for the larger pattern for the 225 PCD. Perhaps Suman, that was maybe something that you can give the perspective on, because it was somewhere where we had some challenges with this sand casting the Turgo.
What happened is, when you make a 3D design, when you give 3D design to someone, like they will give you the exact product that you want, that you are expecting, because I have to send it back once. Yes, all 6 of them. Because the quality they have sent us is not that good. And even in the other thing is, during sand casting, what happens is there is always this what it says shrinkage part, and shrinkage part is not always like rocket science, not always exact. So it can be different in different buckets. You got one bucket of like if you make a weight or if you measure the thickness, it's different from one bucket to another all the time. So it's probably due to the shrinkage. What shrinkage in Nepal they says is in between of 2.5% to 2%. So it can be in between of those range at any time. Yeah, and the problem for us after having those sand casting is how to get in the proper shape and desired desired angle. That's why we have this another jig as well for after machining to check it if it fits exactly or not. So some of the buckets we can finish in 1 day, some might take 3 days, you know, depending on the quality of the sand cast, how good casting we get. Another challenge we get in the Nepal is we don't have any testing facilities to check how is the bucket inside. Like it can be hollow inside sometimes. I have seen many of those kind of bucket in filter. So how we figure out how if there is a hollow or not is just simply weigh them. How much is difference in the weight of each bucket, and then from that we will choose the best one. If that answers any of your questions.
Yeah, it does. Or yeah, what Joe had mentioned. Yeah, I think it's good to remember that in terms of further developing, it is not just the range, but also, as Sam had explained, the material, the type of manufacturing, all of this can be built onto this open source design based on your local location. Yeah, so we will break into the groups now. And this last question we can answer in the group, if that's okay. Or actually, Joe, would you like to answer it now here? Oh, yeah. Well, the question is, there's a certain size and setup, and whether you could support them to fabricate the turbine.
Yeah, I mean, so is this the question with the using belt and pulley transmission system?
Yes.
Certainly in Nepal, there is like good experience from with manufacturing turbines with belt and pulley transmission. So I think the design for the turbine doesn't change. The thing that may change is the size of the shaft to account for having this additional pulley. But so we could definitely support in calculating any change in the shaft that's needed, and then also what dimensions the pulleys would need to be. So yeah, that we can support in that.
Yeah, on the top of that, this Gabriel Brothers, I understand that you are already making cross flow turbines, and most of them are the built as well. So I don't think it will be the very difficult approach to change from drive system, only the drive system. It works in the same principle, just as the generator RPM. So you just check the pulley diameter, change the pulley diameter to match the generator RPM. And there was another question, casting. We still need to use a milling machine. Yes, of course, the milling machine is important. You need to mill after anything, but even if it is a very good casting, you have to do machining. Yes, it is important.
Okay, great. Thank you very much. Yeah, so you will still have an opportunity to share more. We would like to break into rooms based on your level of manufacturing experience, but this is not a binding group. It's only for this live session, and it's not placing judgment or anything like that. It's only so that the discussion and questions and etc. can be most useful. The moderators would facilitate based on this experience level. So in room A, we would appreciate if those that have Pelton turbine manufacturing experience, that when we open the rooms, you select room A. And then for those that have manufacturing experience, but not yet the Pelton, you can choose room B. And for those who are very interested, but still need to build manufacturing experience, you can join me in room C. So with that, we'll just open the rooms and we'll meet for about half an hour. Okay. Yeah, so you can go ahead and choose your rooms. There won't be anyone here in the main session anymore until about half an hour from now. Okay. You would have received an email, but even if you haven't yet received it, if you go to the seedlearning.org and then go to the e-learning tab here and scroll down to course 4, you will see the 4 modules. And to get into the platform, you would use your email address, and there was a default password that was sent. And you can, if you haven't received the email, you can contact us and we'll send it to you again. But yeah, for those who haven't taken the first 3 modules, you could do those. But otherwise, if you have done those modules, you can go into module K, and you should already be enrolled, but might still have to click this button. Not the... Okay, so yes, once you're into the module, you can click on Start Course. And here at the top left, if you click on that, there's a drop down of all the sections in this module. And you'll see that there are also quizzes after the main sections. And so basically, there is a video that you will watch. And after the video, there will be a quiz, and then there are supplementary materials. And in this one that I'm in, this is actually the last one. This is where the 3D CAD files and drawings are located. But we very much recommend that you go through in order the different parts of this module. And there are other links to articles and other material that can be helpful. But Joe has done an excellent job of preparing these videos. I'm not sure what is wrong with this one. I will be checking on that immediately. But yeah, these are the 4 main sections. This module is not as long as the other ones. And the second thing I want to show you, which was in the orientation email sent to you, is that over the course of the week, if you have questions, burning questions that you want answered before the next live session, you can actually write them here. Those who've done this before know it well, but you can write your information and then your question, and the team would answer it here, also allowing everyone to benefit from the question answer. And that's basically it. Does anyone have any questions? Feel free to unmute yourselves.
Yeah, that second video was not working since beginning. When I checked it, it didn't work as well.
Okay. Yeah, I will ask our multimedia person soon. Okay. Yeah, if not, we can close this live session. Just to remind you, the next live session is on Wednesday, June 29th. So you can, in real time, ask more questions, and we may have other things planned for that session. And then I would like to leave you with a very, very interesting video biography that was recently released by Sumanji's team. It is actually the journey of his father, who created Nepal Yantra Shala. I am losing my memory. Who created NYSE, and it's just a fascinating visual journey of how not only of how the Nepal sector developed, but also how the role that a local manufacturing company plays in building the sector. So I encourage you to check that out. You can find it easily on our blog page. Under Nepal, you will see the article. And then if you haven't seen it, there's a very short video about our work. And I can see if the video that Joe showed is also available. That was an excellent video, and any other resources. But yeah, with that, I will bring in the other speakers, and yeah, we can close this session. So yeah, yes, someone had a question?
Yes. What about what was going on in the other groups? We would like to know.
Oh, okay, sure. Yeah, we can do a report back. Should we start with Group A's report back?
Yeah, sure. I can summarize.
Okay.
So yeah, we met turbine manufacturers from around the world. We Nepal, Nigeria, India, Kenya, Malawi, and Sri Lanka. We had representatives from all those countries. We had some good discussions around casting. What are some of the challenges, and what materials are available, and what are the limitations in the use of some of those materials. As that is relevant for this Turgo turbine design, it's interesting to hear about the challenges that people face, and it's something to be aware of in how the design might be used.
Okay, great, thank you. Yeah, and then Sam, you were looking at Group B? Okay.
Yes, so in Group B, we started to introduce everyone and realized it was going to take almost as long as the whole session, so we sort of stopped halfway through. But it's really nice to meet some or get a good introduction from some people. And very similarly, we sort of had people from all across the world, which is fantastic. We talked about materials for casting, so looking at what different types of materials, cast iron, ductile iron versus aluminium and bronze, and trying to understand that a little bit more. And just and sort of 3D printing opportunities as well. And we're actually discussing that even if you don't have local capacity for 3D printing, then actually you could talk to another manufacturer who might or buy that capacity in, rather than having to have your own 3D printer there. And I think that sort of sharing and networking across the HPNET group will be a really really strong part of what you can achieve through this. So I think that was really encouraging, that discussion as well.
Yeah, wonderful. Yes, in our group, we have a very strong interest to make small-scale hydro happen in sub-Saharan African regions. However, the hands-on experience level at this point is not there yet. We did have Nasini from Nigeria, who does have manufacturing experience, but otherwise, yeah, so a lot of the discussion focused on not just the manufacturing part, but also identifying sites, how to collaborate with those that have some experience. Yeah, maybe it's not the Turgo to start with if we're first doing initial manufacturing. And then we talked about the role of this course being more of an exposure, and also would help us evaluate whether the material is useful or not. So yeah, I hope that helps, Rams. Yeah.
Yes, Deepti. Thank you.
Okay. Yeah, great, everyone. Thank you for taking your evening, afternoon time to join. And yeah, we're very excited about this initiative and using this approach also perhaps for other technical common challenges. And yeah, we look forward to having you go through the e-learning platform and let us know if you have any issues or anything. We will reply promptly. And we look forward to seeing you at next week's session. Okay, with that, say goodbye.
Thank you. See
Thank you very much. Thank you.
And thank you very
Adios.
much to our speakers. Yeah.
Bye.
Thank you so much.
Thank you very
Thank you
much.
very
Thank
much.
you.
Bye, everyone.
Thank you. Thank you very much.
Thank you very much. Bye.
Thank you very much. Bye.
Thank you very much.
Thank you.
Bye.
Bye.
Thank you very much.
Bye.